All right, so welcome to Flight Controls and Hydraulics. We'll be going through kind of the same standard format. We'll do the flight control portion. It's a very cursory kind of view on the flight controls. And then we'll go into the hydraulic system with enough detail that you kind of understand how everything works. We'll talk about some malfunctions that could potentially happen and the fixes. So if you want, when we get to that section, you can have your T6 unit developed checklist handy with the emergency pages so that you can follow along in any of the checklists that you might need to reference. This is scheduled for, I think, a little over an hour. It takes about that length of time. So if we need a break, I'll stop when it's appropriate. Here's a little T6 flying along with its gear down and its flaps in the takeoff position. When the gear handle is raised, the inboard gear doors open, all the gear retracts, the inboard gear doors close, and then obviously the flaps come up. So both of those actions require two actuations inside the cockpit. To raise the gear, you raise the gear handle. To raise the flaps, you raise the flap lever to the full up position. So those are two of the hydraulic components that are operated on the T6. All right, primary flight controls. The control stick in both cockpits are interconnected with the interconnect tube. It's got a series of push-pull rods and a bell crank. All a bell crank is for the engineers and the non-engineers is it takes a rotational force and converts it into a lateral force. So by moving the control stick, this is rotating this rod, and then it's moving the bell crank to move the control surface. They're interconnected to each other, and when the left aileron goes down, the right aileron goes up, and vice versa. So if the pilot in the front seat is moving the control stick, the rear cockpit control stick will be moving as well. Just like the PCL, just like the rudder pedals. So they're all connected. There is a maintenance adjustable trim tab on the aileron itself that is not to be touched by the air crew. That is set based on feedback from the forms, i.e., hey, I'm having to put in 4 or 5 clicks of left aileron trim just to maintain level flight on every sortie. They'll go in there and they'll manipulate those ground adjustable trim tabs so that the pilot doesn't have to do that in the future. We'll start way in the back. The ailerons move the aircraft around what axis?
Longitudinal.
Yeah, the longitudinal, the long way on the T6. Or the roll axis. Notice the deflection on the ailerons in the video. Right one goes down, causes it to go up. Left one goes up, the right one goes down. Again, we spared no expense for your training. What are the aileron trailing limits? How much does it move?
20 to 11.
Nobody cares. Nobody cares. Okay? It's not testable. Don't worry about it. So 20 up, 11 down. The big thing to remember here is the aileron surface is the trim surface as well. So that only trims a few degrees. I think it's about 5 to 7. The build will show it. But that gives you enough lateral stick authority. If you ran full aileron trim left or right, you still have enough stick authority to roll the aircraft on the longitudinal axis. During your walk around, did Mr. Copeland or Mr. Eric talk about the mass balancing on the control surfaces? What does it do? Go ahead. Exactly. It moves the weight of that control surface along the hinge line, helping with the center of gravity. Allows it to be basically balanced. So when you let go of the stick, it doesn't just flop one direction or the other. That's really what it does. It puts the weight up along where the hinge line is. That's all mass balancing is. You may see that again. On the control sticks as well, they're still connected via the interconnect torque tube, but when you pull fore and aft on the control stick, you're pulling the elevator cables through the downsprings to the push rod to the elevator itself. So there is a series of pulleys that run through basically the longitudinal axis of the aircraft back to a push rod that deflects the elevator up and down to make the aircraft move in what axis? The pitch axis. The only thing I didn't talk about was the bob weight. What does the bob weight do? Why? Because you go to the gym a lot? Without that, because of the mass balancing on the control surfaces, it would take a very light touch to manipulate the flight controls, unless you're at very high speeds where you're putting a little bit of load on the flight control surfaces. The bottom line is without that bob weight in there, you would over-control the aircraft. The potential to over-G is fairly high. So it gives the stick some artificial resistance, especially for the Marines who are more swole, right? So that's what it does. And we just talked about that. It gives the stick a heavier force so that you prevent over-controlling, i.e. over-G'ing or over-stressing the aircraft. It's basically a spring in this front-mounted box here that prevents the stick from just moving very easily. We don't have that in our current simulator. Cool. Good, we're not quarantined on the base. I can go home at the end of the day. Yeah, our current simulator doesn't have it, so the stick is relatively weak, if you will. It doesn't take a lot of strength to move the stick around. So most students early on have a tendency to over-control the simulator. You'll just adapt to it very quickly. All right, where did I leave off back there? He's heads down on me. What's the purpose of the elevator?
Elevator to control it.
Yeah, to control the aircraft in the pitch axis. And of course, there is a build with a demo. Elevator goes up, tail goes up, nose goes down. So that brings up a good point. In the testing question bank, it'll say, in order to move the nose of the aircraft down, what does the trailing edge of the elevator have to do to move the aircraft? So I'll know when you guys are on that question because I'll see this kind of stuff going on. Just remember when the elevator is curved down, it forces the tail up and the nose of the aircraft down and vice versa. Does anyone want to see that demo again here? Trailing edge goes up, tail goes down, nose goes up. Trailing edge goes down, tail goes up, nose goes down. So if you can kind of remember that little 10-second video there, you'll be good. And more importantly, it controls it in the pitch axis. If you move the control stick forward in flight, what happens?
Pitch down.
The aircraft will pitch down. What does the trailing edge do?
Pitch down, the elevator goes down, and the tail goes up.
Very good. So all of those things. The trailing edge goes down, the aircraft nose pitches down, but the tail goes up. There's variations of that type of thing. I didn't write it. The guys that did live down this street and in the very first building. They used to work for me. They don't anymore. The rudder, just like the control stick, they are connected. So if you move the left rudder pedal in the front cockpit, the rear cockpit's going to move as well. So they are interconnected. They run through a series of cables similar to the elevator, and they go back to the bell cranks that deflect the rudder itself. There is a centering spring on the rudder. So even though it is mass balanced, when you take your feet off the rudder pedals, it'll spring back to a centered or neutral position, which is very helpful. Because most people fly with their feet lightly on the rudder pedals, and without that, you're going to bias the rudder a little bit. So I'll be sitting in the back seat, and the plane will be flying like this. I'll be like, take your feet off the rudders. Thank you. What's the purpose of the rudder system?
For yaw.
It controls the aircraft in the vertical or yaw axis. Same thing. Deflects right, tail goes left, nose goes right. Everyone good on that one? What happens when you stomp on the right rudder pedal?
The tail's going to go to the left, and the nose is going to go to the right.
Correct. And the tail goes to the right. So if you step on the right pedal, the rudder deflects right, the tail goes left, and the nose goes right. How do you adjust the rudder pedals in the T6? Does anyone know?
So a rudder, position hand crank.
Yeah, the little hand crank down by your feet. That's independent of each cockpit. Obviously, people are shorter or taller than each other. So you can set that pedal position. Crank it to the left, it moves the pedals away from you. Crank it to the right, it comes forward. We don't have that system in our simulator. We've got something a little bit better. We have F-35 rudder pedals in our sim, which are really nice. So you just grab the little handle down below. They're spring loaded. So you just pull it out and the pedals come all the way to you. And then you just push your feet back to where it's comfortable and let go. And it stays right there. So it's easier to do in our simulator, but the rotation pedal in the aircraft is a crankety, 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 which gets jammed a lot and it's a lot of fun. Okay, any questions on the primary flight controls? Just remember the mass balancing. Remember the interconnect tube between the control sticks, the function of the bob weight. Those are some key elements to take away on the flight control surfaces. And then obviously the movement of the aircraft. So it'll be fun watching you guys go. Secondary flight controls. What did I ask day one? What are the secondary flight controls? Trim. Very good. So for the ailerons, it's electrical, mechanical movement of the ailerons in the direction that you're trimming. The ailerons are the only surface that the entire primary flight control surface is utilized is in the trim system. The elevator and the rudder have a trim tab. Bless you. No corona? Okay, good. You're not running a fever? Okay, good. So it trims the entire surface. For the elevator and the rudder, there are little trim tabs back there, and those are electrically operated. And we're going to, on the builds, it's going to show how to do rudder, elevator, and aileron trim. So I just went over this. Should be a throwaway. The ailerons, very good. Which primary flight control surface actually moves as part of the trim system? The ailerons. And that is the amount of trim. So if you remember the actual stick deflection that you can do on the ailerons, 20 up, 11 down, well, you can't trim the entire, amount of travel on the ailerons out of the system. So you still have lateral stick authority, which would make sense. If you had some sort of runaway trim issue and it trimmed it full left, you wouldn't have the ability to roll the airplane. Where are the trim controls for the aileron, the elevator, and the rudder?
The aileron and elevator are on the control stick.
Okay.
And the rudder's on the PCL.
On the front part of the PCL. Very good. And here's a picture of it. So this is the little trim hat on the control stick. So if you trim fore and aft, that's the elevator. Left and right is the aileron. What's this button next to it? Trim interrupt. It's the trim interrupt button. So when I press and hold that, I disengage all trim power on the aircraft. If I let go, what happens? It all starts working again except for the TAD, which you have to physically turn back on because you've interrupted power to it and electrically kicks off. But we're going to cover that in more detail. And then, it's a bad picture, but if I'm sitting in the seat, I'm reaching my hand like that. So the front part of the PCL, these two fingers, they run the rudder trim. And you'll be using that quite a bit. What's the function of the trim disconnect switch?
Removes trim and turns off for the TAD. And just leaves TAD.
Correct. It's down next to the lighting panel. It's right here, trim disconnect. So if I go from the normal position, which allows all the trim axis to be powered, and I go trim disconnect, I've removed all power to all of the trim. None of the trim works. Rudder, aileron, elevator, none of it works. And it also disengages the TAD. Go ahead.
If you have it trimmed out, will it go back to neutral, or will it stay in whatever trim setting?
That's a great question. I haven't heard that one for a while, but that is a great question. If you interrupt or disconnect the trim, it stays exactly where it was. It doesn't recover back to any kind of neutral type position. So if you've trimmed really nose high and then you go trim disconnect, you can't trim all of that nose high trim you put in. So it'll stay in that position. So this is your trim gauge. Aileron, rudder, elevator. And then green marks are the takeoff trim setting. Go ahead.
The purpose is to help with like runaway trim and stuff.
Yeah, we're going to get to that in the malfunction section. So that would be one issue. Runaway trim is not really an issue in the T6, the way the system's built, but there is a checklist for it. And we'll talk a little bit about that. What indications would I have if the trim disconnect switch was actuated in the aircraft? What would I see on my annunciator panel?
Trim off, TAD off.
Correct. I would see both of those lights illuminated. Would I get an Aural warning tone and a master warning or caution light? Would I get that? No, because these are advisory lights only. Remember, the Aural warning tone, caution, and warning lights only come on with a red or amber light in the cockpit, not the advisories. I think I mentioned that yesterday. How is electrical power provided to operate the aileron and elevator trim system?
Battery bus?
Yeah, trim's pretty important, right? Important stuff you'll find is on the battery bus. Stuff that isn't important, like the speed brake, well, that's on the generator bus. Yes, it's over on the battery side. Battery on the left, generator stuff on the right. So it's a bad schematic. There's actually the actuator, they're trying to do a cut through, but it sits right in the middle of the fuselage. That's the wing-mounted actuator. And then it's displayed on the cockpit right in front of the light panel on the lower part. So that's where your trim indicator is. Elevator trim, the elevator trim tab. It's displayed on that as well. Notice the downward trim availability is much greater than the upward. Why would that be? Does anyone know? Anyone take a guess? You don't want to guess because you are scared you'll have to do redemption again. Okay, so the reason it's like this is the T6 is slow. It's a slow airplane. So to compensate for that, I have to use a lot of nose-up trim. In order to do that, I deflect this trim tab down, driving the elevator up, holding my nose up. That's why it's built that way. And then the rudder trim tab, it's got 9 degrees movement both sides, it's more gee whiz. And that is operated via the trim switch on the PCL. Again, your trim display indicator is located right down below on the left side of the side lights, and that is your cockpit trim location displayed. So the trim aid device, computer adjusted, so part of your ground check will be to check all of your trims. You'll run the aileron fore and aft, the elevator fore and aft, the ailerons left and right, and then you'll run the rudder trim left and right and leave it out of the green band. Because later on in the checklist, after you get the engine started, you'll engage the TAD, the annunciator light will go out, and then the system will drive the TAD into the takeoff position. It's supposed to do that automatically, and we check that on the ground. So the TAD, it's computer adjusted. It takes in pitch rate, torque, altitude, airspeed. It goes through a little gonculator, and then the TAD maneuvers the rudder trim tab appropriately. Now, I will tell you it lags a little bit, so you're going to have to use rudder trim. There's just no way around it. But it's a pretty good system. Maintain balanced flight. Like I said, it does, but it's a little bit of a lag. You're going to have to use rudder trim. What 4 factors does the TAD take into account?
Pitch rate, airspeed, altitude, and the torque.
Okay. Pretty important. We've went over this several times. You'll probably see this again. Pitch rate, airspeed, altitude, and torque. So like I mentioned briefly, part of the normal checks once the engine is started is to turn the TAD on, and it will move from wherever the rudder trim setting is when you got done doing your check. It will move it to the takeoff position. When will it start providing inputs? It says the computer will make inputs. When does it do that?
When you are above 80 knots and there is no weight on the wheels.
Correct, 80 wow. So above 80 knots and no weight on the wheels, then the TAD will start putting in inputs. It does that so that when you're on takeoff roll and you're using a little bit of coordinated rudder, it's not fighting you going down the runway, which would make sense. The last thing I need is something trying to steer me while I'm trying to steer. It's like 2 people trying to grab the steering wheel at the same time. Like your driver's ed teacher trying to keep you on the road while you're trying to steer off the road. That's what happened in mine. So yes, this is very important. The TAD won't make any inputs until there's no weight on the wheels and you're above 80 knots. Very important. Now, the trim aid device is an electromagnetically held switch. Notice it's got the little red grommet around it, which means it's an electric switch. So when you move it into position, if power is disrupted to it, what's going to happen? It kicks off. It's only in the front cockpit. So you'll hear, hey, can you turn on the TAD? Hey, can you turn on the TAD? Because you guys invariably will either bump the trim interrupt button, which kicks it off, or you'll just forget. Hey, turn on the TAD. So the trim interrupt button. Again, if I press and hold the trim interrupt button, I've interrupted power to all the trim axes, and I've disengaged the TAD. If I let go, all of my trim works, but I have to turn the TAD back on. Removes power to all trim and turns the TAD off. If the gust lock is installed properly, how will the control surfaces appear when you go out and look at it? Was there one in the hangar that was set up that way? What did it look like when you got there? Anybody? Go ahead.
The aileron and rudder will be controlling the elevator.
Correct. It looks like that. Everything is neutral except for the elevator, which is in a down position. And that's because the control stick is usually a little bit more forward than that for level flight, and because you're pulling it back to lock this lever in place. Or I'm sorry, I said the opposite. It's more forward than normal because it's so close to the bulkhead, so it's going to be in a down position. All right, any other questions on the flight controls? Okay, good. Hydraulics, we're going to go through the entire hydraulic system, and then we're going to cover the abnormal conditions. Memorize it. No, I'm kidding. You don't have to memorize it, but it's a good schematic. It's found in your -1. So we'll just go through that, the schematic briefly. There are 5 systems associated with the hydraulic system. We've got the Nosewheel steering, landing gear extension and retraction with a centering spring, the inboard gear doors, the speed brake, and the flaps. So they're all located on the various systems. All of the pressure comes from the engine-driven pump. That pressure is supplied to all of the lines via the green side. The pink side is the up and down actuators that come from the main system. The red is the pressurization that goes into the accumulator. And then the yellow is the emergency system. Now for the emergency system, it only is supplied to the downside of the actuator, which would make sense. If I'm using the emergency system, I want to get my gear down and my flaps down. I don't need it to bring the stuff back up, and we're going to cover that a little bit later. There's 2 lights associated with the hydraulic system. There's hydraulic fluid low and emergency hydraulic pressure low. And we're going to cover those as well. So this schematic is actually pretty decent. What components are operated by the primary or normal hydraulic system?
Land gear and the main gear forward.
Okay. Is that it?
And the flaps and the speed brake.
And then Nosewheel steering. So there are all 5. So the inboard gear doors, the main landing gear, all the landing gear, extension and retraction, the flaps, the speed brake, and the Nosewheel steering. All right, which component is the source of pressure for the system? The engine-driven hydraulic pump. That's where it gets its hydraulic pressure. What's the system pressurized at?
3,000 psi.
3,000 plus or minus 120. Very good. The engine-driven pump. What color indicates that the pressure is in the extended scale, but it's still in the safe range?
White.
White. So just like most of the gauges in the T6, the green area, green and white, good for flight. So the green scale normally will indicate that that's in the normal operating range. In the white scale, the -1 says that the hydraulic system should continue to work. It may be slower and or degraded, but it should still work. Amber, all bets are off. Okay, it probably won't work. When the hydraulic fluid low light indicate, what does it indicate for us?
The amount in the reservoir is less than 1 quart.
Yeah, it's probably not good. We've got a leak somewhere is typically what happens there. The system holds about 6 quarts, give or take, depending on how it's serviced. So if it drops to 1 quart, then you probably have a leak. So you'll have to use the emergency system more than likely, unless you've got normal hydraulic pressure. What's the purpose of the emergency hydraulic system?
To give us flat, or in case the primary system fails, we still use our flaps and landing gear.
Okay, it's a one-time actuation of the landing gear and or flaps. plain and simple. It's actuation only, not retraction. That answer is word for word what you need to know. It's a one-time lowering of the landing gear, doors. I say and or flaps because you may not need flaps or want flaps, but it's available to you. So how does the emergency system work? Well, the engine-driven pump charges everything to include, go ahead.
Sorry, a question for the flaps. If you actuate the system and you use it to lower your landing gear, and then you wait a little bit, how much time do you have to lower the flaps? I mean, is hydraulic stuff, the pressure eking out? I mean, do you have to do it immediately if you need flaps, or?
So, how do I explain this? Okay, so who's been like to a little kid's party that's got the little pink canister of helium and they're filling up balloons? Okay, that pink canister is your accumulator. So if you use pressure out of it, then that pressure inside that vessel is down a little bit.
Right.
But the -1 says that accumulator has enough pressure to blow the gear down, the inboard gear doors, and give you an extension of the flaps all the way. So to answer your question, as much time as you need. But if I put the gear down, I've got a little less pressure, but still enough to get the flaps where I need them to go. Does that help?
Sir.
Good question. Okay, so the engine-driven pump not only pressurizes all of the normal lines, but it comes down here through a one-way valve and charges basically my helium piston. There's pressure on the backside of that helium area, and it's being smushed, if you will, by hydraulic pressure. And it's charged to 3,000 plus or minus 120, whatever the hydraulic pump is producing. The bellows, that's just a fancy name for the storage vessel. When I pull the emergency landing gear extension handle, I've locked out the normal system at the power pack side assembly. I have basically nullified all of my normal hydraulic pressure. It's separated, if you will. So it gives me, on the extender side, my landing gear, the actuator downside of my inboard gear doors, and allows me the downside of my flaps. So if I pull that, I'm automatically going to get the inboard gear doors and the landing gear. When I use my flap lever, then I will get my flaps to come down. So it's not sandals, it's not all inclusive. Okay, you're not going to get everything coming down all at once. You're going to get gear and inboard gear doors if you pull the handle, and then you're going to get flaps when you lower the flaps. Now, let's say I have a normal hydraulic failure and I want to put my flaps down. How would I put my flaps down? Can I just lower the flap lever? I have to blow the landing gear down first in order to use the emergency flaps. Does that make sense? So this has to be actuated first in order to use the flaps. Do you want to try it again?
3,000 plus or minus 1.
Very good. 3,000 plus or minus 1. And I think it says something about quantity there. Pressure and fluid quantity. It doesn't really say, but it holds about 6 quarts. That's not really that important. The most important piece is I get the the low light when the system drops below a quart. What's the width of this green band, by the way?
240.
What if I said it was 2880 to 3120? Because that's the normal operating range. That's why it's painted green. Okay. On the walk around, the hydraulic servicing panel is on the right side after the wing. There's a little drop-down panel. There is a glass slide tube for those that couldn't see it or didn't care to bend down there and go, ooh, that's where it is. A full accumulator discharge or a full accumulator charge. These two little green bands, there's a rod that slides inside of this glass tube that's under pressure. So when you look at it, it should either be here or here. If it's somewhere in here, well, then the system needs to be serviced because it's not at the right thing. So after you land, there is a handle that's just outside the frame where the crew chief will pull that to discharge that accumulator pressure, to bring that down. It doesn't need to sit there all charged up. So it goes down here, I'm sorry, to accumulator discharge, and it sits down in here. If I get in the aircraft and I start it up, I'll have the emergency hydraulic pressure light on for a minute. When the engine's running, gets up to speed, and the hydraulic pump produces enough pressure, eventually that light will go out because now I've compressed that helium precharge and my system's armed and charged up. So once I land, if I open that panel, this green bar is going to be over here. And that would make sense. That storage vessel is still charged with hydraulic pressure until I pull that handle and discharge the pressure back down to here. That's all it is. This is the servicing port for the hydraulics. So they'll hook up a servicing line to that if it needs to be serviced. If for whatever reason that accumulator is not charged up properly and the pressure drops to what? 2400 plus or minus 150. It's not at its 3000 plus or minus 120. It's dropped far enough that now you get a light at 2400 plus or minus 150. So those are the two lights you get with the hydraulic system. Go ahead.
At 1800 PSI, that's when flaps and stuff start working, correct?
I don't know what the bottom of the white band is. It's pretty low. It's down there.
So my question is that going to be lit up then once you start up the engine while it's building up the pressure?
It will be if, from the previous slide, if the crew chief had discharged the accumulator, then you're going to have that light because the accumulator pressure is zero. It's all the pressure's bled out of it. Until it builds up pressure above this threshold, 2400 plus or minus 150, then that light will go out. And I'm flying around. And then when I land, I'll discharge the pressure out of that. Go ahead.
When you pull the landing gear emergency handle, is that going to pop up then? Like send some of the pressure?
No. Okay, having flown FCAF flights, which means functional check flights, one of the things we would do is when we bring the aircraft back for its last landing, we would use the emergency system to make sure that it worked properly. And most of the time, the light would come on for that last bit of flaps. It would go from flaps from the takeoff position to landing. It would still go its commanded distance, but that light would come on because we're getting pretty low on pressure inside the accumulator. But the dash one says we have enough pressure to put the gear down, the inboard gear doors, and a one-time actuation of the flaps all the way. So to answer your question, yes, that light typically comes on, but not till the last stage of flap actuation. Good question. That's pretty varsity though. If you didn't understand what we just talked about, don't worry about it. Just know that the light comes on the emergency hydraulic pressure light when the emergency accumulator drops below that pressure. All right. Any question on the primary and emergency pressure systems? Okay, let's take a 5-minute break, and then we'll come back in here and we'll talk about each of those components specifically and some abnormal stuff. All right, welcome back. So as promised, we'll go through each of the hydraulic systems, just a cursory overview on how they operate so that you guys have a working knowledge on how those particular systems are integrated with the overall hydraulic system. So the landing gear components, the inboard gear doors are hydraulically operated. They have to physically move out of the way to allow the gear to come down. Remember that the outboard gear doors are physically connected to the strut. So if the gear comes down, they come down automatically with it. There's no system associated with it. The nose gear, which we haven't even talked about, there is a door on the front of the aircraft that is basically a clamshell door. So it stays closed, and then when the landing gear comes down, it pushes the door open with a roller wheel, it's on a spring, so it just opens, and then the gear is fully down. When it closes, it goes back up, and then when that metal roller passes it, it allows that spring to close the door. So it's just a spring door. There's no hydraulics associated with the nose gear door. So the landing gear controls, we have a landing gear handle that has a luminescent bulb inside of it that is usually on if the gear are in transit or you've retarded the PCL below 80%. We have the gear indicator lights. We have a warning silence button. So if you're flying slow and the tone's going off, you can silence the landing gear down tone from the Aural warning generator. We don't use it very often. And then the downlock override handle is a maintenance function. It just allows them to raise the gear handle on the ground if they need to troubleshoot a panel underneath. So this is a video of the normal gear retraction, and I think it does an extension. So right now, this is what you see normally when you're on the ground and the gear are down and locked, to use a Navy term. So all the gear are down, the inboard gear doors are up currently because they're closed, and that's the normal configuration. When we raise the gear, what's going to happen in this video? What's the first thing? Two red lights will appear here and here because the inboard gear doors are now coming down, and the red light in the handle will illuminate because they're not either all up and locked or all down and locked. It's in some sort of transitory state. Then all of these, then the nose gear light will illuminate red because it's in transit. Then eventually, all of the lights will go out minus these two red lights, meaning the inboard gear doors still need to close. And that whole process is reversed on the extension. So let it play out. Gear handle up, inboard gear doors, everything's in transit. All the gear are up, inboard gear doors close. Inboard gear doors, everything's in transit. All the gear are down and locked, inboard gear doors close. So if you remember the very first video associated with the lesson, it showed that gear retraction process. Does anyone need to see that again? Okay. What's the maximum speed on the landing gear? Who's been doing their ops limits? Go.
Sir, the answer is 150.
Okay. Nerd! All right. Conditions for the Aural warning tone. There's a few of them. One of them is the gear handle is not down and your airspeed is below 120 and the PCL is below a mid-range position or 87 N1. It usually corresponds to about 20% torque. You guys very rarely will look at the N1, so it's about 20% torque. You'll also get the Aural warning tone if the flaps are in landing and the gear is up. So you could be in max power with the gear up, but if the flaps are in landing, the aircraft thinks you're trying to land without your gear being down. So it's a physical position of the switch. So until you raise the flap lever, that tone's going to be present. And then the last one, which is rare, if maintenance was doing something and left the gear handle in the up position on the ground, you're going to get the tone when you turn on the battery. You're probably not going to take that aircraft. You're going to be like, whoa, what's going on with this airplane? You can use the silence button. But again, we don't use it very often. So when do we use the emergency gear extension system? Yeah.
When the primary hydraulic system fails?
Yeah, when we don't have any primary hydraulic pressure, there's one other time. Okay, you're on the right track, engine failure. That's kind of normal hydraulics, pressure isn't available. What's the other one? Think electric. Not gen, battery bus. Is the gear important? Gear is pretty important. It's on the battery bus. So loss of the primary system, battery bus, and like you said, engine failure. You could argue that because it's a engine-operated hydraulic pump, when the engine is no worky, neither does the hydraulic pump. So what's the normal sequence for emergency extending the landing gear? Ma'am, I'll pick on you since you're stretching.
Lower the landing gear handle and then pull the...
Correct. If you follow the emergency gear extension checklist, it's going to tell you to make sure your airspeed's below what? You're almost on cue. Almost. It was like almost perfect. That's okay. So below 150, and then you'll lower the gear handle, then pull the emergency gear extension handle. We don't do that on the engine failure on takeoff boldface, or that step would be in there. We don't want to waste time by putting down the gear handle to pull the emergency gear extension. So that's typically how it's actuated. We lower the gear, you push in this little silver grommet so that you can pull. The Dash 1 says it takes about 70 pounds of pressure to pull it. Don't skip arm day. Or fly with a Marine. That's the only option. I could just see you guys in the cockpit. Pushing that thing in, putting your foot up on that. It's not that bad. In the heat of the moment, your adrenaline will be pumping. You'll have that grandma strength with a baby trapped under the car. You'll just lift it right up. All right, flaps. Split flaps, we talked about that even prior to the walk around because of the dihedral wing. There's 3 settings for the flaps. What are they? Correct. Up, landing, and takeoff. Not really in that order. So it'd be up, takeoff, and landing. How do flaps help us? Well, it gives us a shorter ground run because it allows us to get a little bit more lift to have a shorter takeoff. And then it allows us to land on a shorter distance because our approach speed can be slower. So it helps us both for takeoff and landing. The original design on the T6, no flaps. And the Navy's like, okay, we're good with that. Air Force is like, no, we got to have flaps because we need something for the students to overspeed. So that's why they put it on. No, I'm kidding. It just made sense to put flaps on the aircraft, especially on a single engine aircraft that has the potential of an engine failure. And I already talked about that. It allows us to approach slower with the flaps down, causing a shorter ground roll. This is the flap position indicator. It's located right above the landing gear section next to the emergency gear extension handle. That is your flap gauge. Obviously, it reflects the position of the flaps. Currently, they're in what position? They're takeoff position, so about halfway. That indicator is on the battery bus, so if the battery bus fails, you won't get any data on that. It'll just indicate up. Emergency flap operation is not available when the aux battery is the only source of electrical power. That is true. Where is the emergency flap power come from? It's on the hot battery bus wired directly to our battery. So if the battery fell out of the airplane, you couldn't use the emergency flaps, but you probably have a bigger problem, okay? So as long as there is battery power on the aircraft, not battery bus, but battery power, you should be able to use emergency flaps. So that statement is true, it's just a little misleading. Is that good? Does everyone understand that? So basically, if your clock is working, you should have emergency flaps. What's the maximum speed on the flaps? 150, very good. I think we just went through that. Same as the gear. So you only have to remember one number, 150, 150, 150, and some of you can't. And we'll overspeed, and it's a glorious day. All right, it's an electrical switch. What bus is this on? Flaps important or not? Yeah, battery bus, good. Pretty good cutaway. Obviously, this is the selector. This is the torque tube. The flaps are connected to what? Okay, one more time. The flaps are connected to the torque tube. Thank you. There is a failure mode in the T6 that it has a potential of asymmetric flaps. What that means is whether it's this side or this torque tube could bend and twist and fail. If it does, it's probably going to happen during flap extension or retraction. So you could be flying along, okay, gear clear, gear, flaps, and all of a sudden the plane starts to roll. Well, what's happening is this flap is coming down and this one's staying up. The checklist says, okay, airspeed as required, and then actuate to eliminate. So if I lowered them, I'm going to put them back, and then that should go away. You guys usually mess that up. But this is the torque tube, and that's where the flaps are connected. That's the actuator that sends the hydraulic pressure to the lever arm that rotates the torque tube and extends the flaps. Torque tube. Can the flaps be operated in the event that the primary hydraulic system fails? Yeah, that's what we've been talking about. But how would I have to do that? What do I have to do first to use the emergency system? I have to use the emergency gear extension handle in order to use that pressure for the flaps. Yes, after you use the landing gear emergency system. All right, speed brake. Go ahead.
Like putting down the gear in an emergency system, you have to put the landing gear switch down. Do you want to put the flaps to landing before you were to use the flaps in an emergency situation? Like, is there a situation?
You could, but you wouldn't do that.
There's not a scenario where it goes back up because you have a...
No, it never goes back up. Why does it never go back up? Because it's using the same actuator as the normal system, but only on the downside. It has no ability to retract it. It's the same exact actuator, it just uses different lines of pressure. One's a normal, one's emergency, but it's the same actuator. Good question. That's definitely on the test, by the way. Speed brake. What's a speed brake do for us? Slows down. And it increases our rate of descent without decreasing our speed. So what does that mean? I need to get down quick and I'm going 200 knots. If I throw out the speed brake, I can get a little bit more bang for my buck. I can descend at a greater rate. That's all that's saying. That's what it looks like. It's a very simple system. Oh, I got ahead of myself. Where's the circuit breaker for the speed brake? Important or not? No, it's not important, so it's on the, thank you, it's on the generator bus. So the speed brake switch is located up here on the PCL. When you actuate it, you'll get the speed brake light, which appears right above the nozzle steering light, over there above the GPS. Very simple system. The speed brake is attached to a hinge and a hydraulic piston. When it's actuated, the actuator extends the piston and pushes the speed brake into the airstream. When you're done using it, it retracts. There is no inner, it's all or none. It's binary. So some aircraft allow you to fan the speed brake or just put it out a little bit. The T6 isn't that way. You actuate it, you get the whole meal deal. When it's time to go away, you push it forward, the thing clamshells shut. There is no, I'm just going to put it out a little bit. B1, yeah, we could fan the speed brake. But we're going a lot faster. That's what it looks like. Ways that I can retract the speed brake. You try to avoid eye contact. I saw it. What are they? Well, that's one of them, right?
Yeah.
I can use the switch. I can extend it and or retract it using the switch. What's another way I can retract the speed brake? I know you know. Max power on the PCL. So whatever power setting I have, if I push up the power to max, it'll retract the speed brake. What's the last way?
Flaps.
Yeah, if I lower the flaps, or the flaps are out, the speed brake won't extend, and we'll check that on the ground. But if I lower the flaps, it automatically retracts the speed brake. The system prevents that flap speed brake interaction. What if I'm flying along and I throw out the speed brake and I lose my hydraulics? What's going to happen? Yeah, the wind stream will push the speed brake back to a closed type position, not interfering with my ability to emergency extend the flaps. It shouldn't. So speed brake move forward. If you extend the flaps, it'll retract the speed brake. And if the PCL is advanced to max. Those are all ways to extend the speed brake. Sir, what if I'm already in max power and I try to extend the speed brake? It won't extend. You're overriding it by holding the PCL in max. As soon as you break the PCL back and then try to extend it, it'll extend. Then if you tap max again, it'll close. Question?
Can you explain how the speed brake has a nose-up tendency?
How it what?
It gives the aircraft a nose-up tendency.
Okay. Where is it located?
Oh, I guess it's closer to the front.
No, just where's the speed brake?
Okay.
It's on the bottom. So when you put that down in the airstream, what's it going to do to the airplane? It's going to force the nose of the aircraft up. So by extending it, it pushes the nose of the airplane up, causing the nose-up tendency. Think of it as kind of a dirty airfoil, if you will. So it's just going to push the nose of the airplane up. Good question. Nosewheel steering. Normally we don't taxi around using differential braking. This isn't DOS. This is varsity. That's JV. You're now in the varsity. We use the nosewheel steering system because the RPA that you're going to, if you're in an LRU, you're going to be using nosewheel steering and taxi on center lines. It's probably the most dangerous thing you guys are going to do is if you're ever in an LRU is taxi around. Because you're looking through a soda straw in order to taxi. All right. Nosewheel steering, it's on both buses. The actuator's on one and the switch is on the battery. So battery bus and the servo actuator are on two different buses. So you got to have them both or it no worky, San Antonio style. The nosewheel steering button. I've started adding this to my repertoire because we get in there in the very first sim and you're like, nosewheel steering button, you're smashing stuff on the glare shield. No, it's the pinky switch located on the control stick. All it takes is you to click it with your pinky and the nosewheel steering light will come on. To steer the aircraft, once you've engaged the nosewheel steering, we use the rudder pedals. So the rudder pedals not only will move the rudder, but now will drive the nose servo left and right, which is fun. Looks like you guys are experiencing a DUI on your first taxi out because we're going like this. It's kind of fun to watch. Just like driver's ed, less is more. So if you hold the steering wheel relatively still, the car's not going to go all over the road. You guys will figure that out pretty quick. There's the actuator. Again, it's hydraulically powered. That's why we're talking about it. You've got the mechanical portion just below that. That's the gearing mechanism, which will actually drive or turn the servos on the actuator assembly. Selector control valve, we just talked about that. There's the servo valve, which will then allow that mechanical arm to turn the nosewheel steering left and right. It's a rotary actuator, if you were curious, that's how it works. And then a centering valve. So if you're using nosewheel steering for takeoff, which is a no-no on the checklist, and you retracted the gear, it will automatically center to a centered position. So if you took off in a little bit of a crab, it's got a centering spring which centers the nose so that when the nose gear comes up, it retracts straight into the nose gear bay. For a long time, we couldn't slip the airplane because that centering spring wasn't working. So you'd see folks coming in to land and the nose gears cocked off to the side. It's pretty aggressive when you touch the nose down and the nose gear's like that. So if that happened, you were supposed to jam the stick full forward to drive the nose of the airplane straight. There's a few soiled flight suits when that was happening. That's when I first started flying. Luckily, it never happened to me. What happens when you engage the Nosewheel steering at a high rate of speed? Who's seen the show Jackass? Anybody? When like Bam gets in the shopping cart and they tie a rope to it to the bumper of a car and they go up to like 50 miles an hour and it goes like that and then off it goes in the ditch. That's exactly the same thing. It's extremely sensitive. You'll lose directional control. You'll depart the prepared surface. The checklist says disengage the Nosewheel steering as part of the takeoff checklist. You do not want the Nosewheel steering on. It's too sensitive. You'll start putting in inputs and PIO yourself right off the runway. No one will ever forget that analogy. Brakes. Are brakes on the normal hydraulic system? No, they're not. Anyone ever driven a tractor on a farm? Anybody? Okay. Sometimes I have somebody. They work just like tractor brakes, for those that don't know anything about that. So you got the brake pedals. Whoever pushes hardest wins. They're interconnected just like the rudder pedals. So if I advance the brakes and I'm not pushing very hard and the IP jumps on there and pushes harder, the IP wins. So whoever pushes hardest wins. The way it works is you push the rudder pedal. The master cylinder squirts fluid down to the caliper, which squeezes the disc. That's the brake system. It's completely independent of the hydraulic system. Let's see what the courseware says. 2 master cylinders, 1 for each brake, down to the caliper, which squeezes the disc. How can you turn real sharp in the T6 if you had to? Differential braking allows you to do that. Normally we don't use it. The key is disengage the Nosewheel steering first and then stomp on the brake that you want to pivot on. And this will show you the turn radiuses. The parking brake, actuate the brakes, pull out the lever, rotate 90 degrees. That's the parking brake. All right. We'll quickly go through the malfunctions. Rudder jamming, this was a big deal in the T6 a couple months ago. They don't know what caused it. So they basically rub their tummy, pat their head, do a ram dump, and the thing would start working again. So I think it had something to do with the fatigue and time change on the bell crank and the pulley system that goes back to the rudder, but no one ever really confirmed what caused it. The big thing is, obviously, if you've got a flight control issue, you're going to want to do a controllability check. You're going to want to make sure you've got the full range of capacity to fly the aircraft. So you're going to get in the checklist, walk through it. It's pretty straightforward. Runaway trim, we touched on that a little bit ago. If for whatever reason you actuate the trim in one particular axis and then you take your finger off of it, it should stop. But if it runs away, the likelihood of you catching it is this much. I've given it to instructors, students, everybody, and no one catches runaway trim. Oh, this is a little too late. By the time you go, hey, this is a little weird, it's too late. So if you catch it, for some reason you're looking down there and all of a sudden you start seeing it move, how do you stop runaway trim? Trim interrupt button. Boom. Depress and hold it. Why did I say depress and hold it? Why didn't I just say depress it and let go? Because the minute I let go, it's going to start running again. So depress and hold, get your airspeed under control, and then disengage the trim disconnect switch. And that's what the checklist is going to drive you to do. Corrective action, that slide was out of place, by the way. Corrective action, trim interrupt button, hold, fix your airspeed, and then trim disconnect action. TAD failure, it's not really a big deal. What did we lose when we have a TAD failure? The automatic rudder jet-like help that the CHAD is giving to us. Can we still trim the rudder? Yeah. We just don't have that jet-like assist that the TAD gives us. It's not really a big deal. Probably terminate the mission and just come back. What's a possible indication of an abnormal flight control? How would we know we've got something? What's it going to do?
Sluggishness.
Okay. What else? Maybe it's binded up. It won't go. Maybe as you go to push, it stops. So it could be some binding, some sluggishness, unresponsive. All of those things. Ooh, uncommanded. Maybe that pulley or cable broke and it deflected one way or the other. You're probably not going to stay with the air. You might be out of control of that. What's the corrective action if you have runaway trim? What's the first thing you want to do? Trim interrupt button to press and run the checklist. Ooh, run the checklist. Novel. Hydraulics, what did I say about this situation? Is it in this green band or this green band? No, it's way over here. So what do I need? Am I even going to take this airplane? No, not until the hydraulic system is serviced properly. Hydraulic fluid low. When the reservoir drops below 1 quart, we already went through that. Consider inoperative. Guess what? All of our normal hydraulic systems, if the fluid drops below that. What do we still have available to us though if we've got that emergency or a fluid low light on? The emergency accumulator is still available to us. So don't forget that part. What if this comes on? Are we dead in the water? What's not going to be available to us potentially? The emergency side of our hydraulic system. Maybe the normal side still works. So in this case, you may want to put the gear and flaps down in case something else happens on the aircraft. And that's what the checklist is going to direct you to do. If fuel's not a problem. Pressure ranges, what do we talk about? Anything in the green, we're good to go. What about the white? Should work. Maybe it's slower. Might take a little bit of time. Yellow, amber, probably not going to work. And if it's in the yellow, we probably need to use the emergency system. If the emergency hydraulic pressure low light, what devices should you consider inoperative? Think about what it's asking. On the emergency hydraulic pressure, what should be inoperative probably? The emergency accumulator stuff. The gear extension, inboard gear doors, and emergency flaps. So all of the emergency stuff. What's the problem here? The right main isn't down. Well, that's not good. What about this one? The nose gear is not down. Okay? Those are what those indications are. What if this was the front cockpit and this was the rear cockpit? We're good. Any safe gear indication is a safe gear indication. No, hopefully it doesn't look good. I would hope it doesn't look like that. So the main gear is not down and locked. Obviously the right main and then the nose gear. Other ways you can tell if your gear are not down and locked. The taxi and landing light, we talked about, those will illuminate when the gear are down and locked. The AOA indexer up on top of the glare shield, if this is not illuminated with the gear down, your gears are not down and locked. The rest of them, that's going to be tough. I mean, one gear, you're probably not going to recognize that much of a loss in drag or any rolling tendency. That's probably not going to happen. But those other things that we just talked about are probably more indicative of it. The landing gear checklist, garbage. It's garbage, okay? Read through it first is my recommendation before you do any action. Because on step 6, you're gonna already pull the emergency gear handle, or step 7, or something like that. And you're gonna go, well, I didn't need to do that because there was an and or in there. So just read through it. It's a little bit convoluted. It's getting better. They've rewritten most of it. You can see this black bar, but it's always not been very good. We already talked about the unsafe gear. What would I see with one main landing gear down and then, with the main landing gear down and the nose gear still fully up? What would my lights look like? Who wants to field that one? We'll let Marine do it. My main gear are down, but my nose is still up.
So the main gear is down, it's going to be green, and then the nose gear would have...
Anything here?
Would have nothing.
Okay, good. So you have green and red on both of the mains and nothing in the nose, and the light in the handle. Magic. That would make sense because the inboard gear doors won't close until all the gear are down and locked. Here's a question. If I use the emergency system, what's this going to look like?
3 green.
Regardless of the position of the handle.
3 green, 2 red.
Okay, 3 green, 2 red. What about the handle light?
Red. Should still be red.
It'll be red.
Yeah.
Because the inboard gear doors will stay in the down position. It's a one-time extension of the inboard gear doors. That's where you get the 2 red. All the landing gear, 3 green. The gear doors won't retract, so the red light will stay on. That's what you will see if you use the emergency system. Nosewheel steering, it won't work if you've lost your hydraulic system. Asymmetric flaps, what's the likely cause of asymmetric flaps? Who was listening? Torque tube. Very good, torque tube. If I had candy, I'd give you a piece. Actuate to eliminate, step 2. Loss of flaps, not really a big deal. You can land no flaps. You guys are going to practice that several times in the contact. Just going to have a little bit of a longer landing roll due to the fact that your approach speed is now 110 instead of 100 or 105. When lowering the flaps using the emergency system, what conditions might result? Anyone? This goes to somebody asked about the emergency system. Dash 1 says you should get a full extension, but they may only partially come down. That is a possibility, but I will tell you that they'll come down all the way. You're going to get the emergency hydraulic pressure low light when everything's down, more than likely. Speed brake failure, I don't really care. You're not going to get the light. I would also check the position of my flaps. If I'm going to use the speed brake and I go, ooh, speed brake, hey, speed brake's not working. I look down, oh, my flaps are still down. Okay, I'm probably in trouble anyway, but don't raise the flaps because you probably overspent. Not saying I've ever done it, but I've heard people do it. Wheel brakes. Remember, these are master cylinders, so there could be air in the line, so if you go to actuate the brakes and they don't work, come off the brakes and reapply. It's not like your modern BMW 325i that's got anti-lock brakes and all the other Gucci stuff. This is Grandpa Fred's 55 Buick. You just stomp on those brakes. If they don't work, come off, reapply. Maybe only one works. You're gonna have to apply, potentially use Nosewheel steering, gently move back towards the middle, reapply, gently move back toward the middle, reapply, that type of thing. Emergency, the firewall shutoff handle shuts off fuel, environmental stuff, which you guys don't care about, and hydraulic fluid at the firewall. That's where it's located. So in the front cockpit, if you The way that's pictured, you're looking at it this way. So it's back behind you, you lift up this guard, grab the handle and pull it. It goes up about yay high. It's a mechanical separation of those items. How do I know my brakes don't work?
Spongy feeling, going to one side.
No stoppy. You don't slow down. My Spanish is getting much better after living here a while. Yeah, you could have the, one brake working and one not, so you could get that pulling one side or the other. All right, let's go through the questions. You're like, oh, we're done. Oh, no, there's questions. Let's start all the way in the back. No, we'll start up front. Marines haven't been included very much. I'm sorry. We'll get you in there. All right, question one for you. You already know the answer.
So lateral axis.
Elevator controls the pitch lateral axis. The ailerons move opposite each other and move the aircraft around which axis? Correct. The rudder causes movement around the vertical or yaw axis. The ground adjustable trim tab is found on which control surface? The ailerons, adjusted by maintenance. What are the factors used by the TAG computer?
Engine torque, airspeed, altitude, and
Pitch rating. Learn it, live it, love it. Once takeoff trim is set, there won't be any inputs made until when?
80 knots and weight off the wheels.
80 knots and when there's weight off the wheels. Primary and emergency hydraulic systems are pressurized to what pressure?
3,000 plus or minus 120.
Correct. What's the function of the hydraulic system, engine-driven pump?
It creates hydraulic pressure and transfers it to the emergency accumulator.
Yeah, it does both. It gives us pressure in the normal system and charges our accumulator. The emergency hydraulic system services which components?
The landing gear, inboard doors, and the flaps.
Correct, and it's extension only. One ping only, sure. Hunt for Red October. When extending the landing gear, which gear door ultimately closes as part of that sequence?
the main inboard.
Yeah, once the gear are down and locked, the inboard gear doors are the last to close. That's what they look. They're yellow. They're painted yellow. No, I'm kidding. They're just highlighted. What does the red light in the landing gear selector handle indicate when illuminating?
The gear doors aren't closed and the details of the gears up.
Okay, so it has a couple of different things. One, the gear in transit, perhaps, maybe an unsafe gear, or the PCL is back below about 20% torque, mid-range or 87 and more. So there are some different nuances to that question. What happens when the Nosewheel steering if the hydraulic system fails?
Stop working.
Oh, you had an opportunity. You could have said no working. That would have made it better. Does not operate. What happens when the speed brake, or what happens to the speed brake if the hydraulics fail?
Won't work.
It doesn't work. It's on the hydraulic system. The flap should not be operated above what airspeed? So you missed it by one question. You already got that. When completing a sharp turn, how should the Nosewheel steering be used?
You should use it.
Yeah, do not use it.
No
No using. No. Do not use Nosewheel steering if you're going to make a tight turn because you'll drag the nose gear. The field of use is very, very small. What causes that emergency hydraulic pressure low light to illuminate?
Low emergency hydraulic pressure.
Very good. What pressure does it have to be to illuminate?
2400 plus or minus 150.
Correct. The light comes on when the light comes on. All right, we have use of the speed brake with the emergency system.
No working.
You will not be able to use the speed brake. can you expect to use wheel brakes if the primary hydraulic system fails?
Yes, so it was,
Yeah, it's a completely separate system. 2 master cylinders, et cetera, et cetera.